Humans have been exploring space for decades now. Normally, we're the ones that go visit the far ends of the solar system and beyond to discover things that we can't with a regular telescope. The general idea is that these things exist, they're there in space, and we just have to go and find them. But with the discovery of Oumuamua, all of that changed. In a jaw-dropping twist that sends shockwaves through the scientific community, join us as we embark on an extraordinary journey, peering into the very fabric of existence, where the mysteries of Oumuamua await their long-awaited unveiling. In 2017, an astronomical event unlike any other occurred. For the first time, we spotted an object that we believe originated beyond our solar system. Its origin was once a source of controversy. Was it a comet, although with a peculiar orbit? Was it an asteroid because it didn't have a noticeable tail? Or was it something completely unique? A visitor from another galaxy and the first instance of an altogether new kind of object. It was named Oumuamua, which means messenger from the distant past in Hawaiian, and it became a magnificent discovery as well as a glimpse into what items exist across interstellar space. But one scientist, enamored with his own notion and ignoring the extensive study done by other experts who specialize in this subject, has gone on a public crusade to persuade the world of the most implausible explanation for this natural phenomenon: aliens. For the better part of 4 years, Harvard astronomer Abhi has been all over the media, rallying popular support for a theory that defies scientific proof. Contrary to popular belief, including that found in Loeb's new book, Extraterrestrial, the first sign of life beyond Earth, this is not a possibility worth considering as a scientist. A simple examination of the evidence reveals why. Every object gravitationally impacted by the Sun will follow one of 4 orbital routes, according to the law of gravity: circular with an eccentricity of 0, elliptical with an eccentricity larger than 0 but less than 1, parabolic with an eccentricity precisely equal to 1, or hyperbolic with an eccentricity more than 1. When it was closest to the Sun, it was traveling at incredible speeds, up to 88 kilometers per second, or 3 times the speed at which Earth circled the Sun. But we were lucky to have captured it at all. It was tiny, approximately 100 meters long, dim and bright red, comparable to the Trojan asteroids that circle Jupiter. Its color differs from that of known frozen things, failing to match comets, Kuiper belt objects, or even centaurs, and further examinations showed a certain level of boredom in Oumuamua, since it exhibited no molecular or atomic absorption or emission signals. In fact, if it weren't for 2 peculiar characteristics of this object, there would have been little to notice about it, other than the fact that it exists and follows the course we saw. The first unusual aspect of Oumuamua was discovered in October of 2017, shortly after its detection. We only had a brief window of opportunity to make follow-up studies because it was pretty close to Earth, but yet traveling away very rapidly, so a number of telescopes set their sights on this cosmic oddball. The brightness of the object fluctuated by around a factor of 15 over a timeline of about 3.6 hours, but not on a regular basis like clockwork. Models of this object suggest that it is both elongated and tumbling, which would explain its frequent extreme brightness changes. This is a good explanation because unless there is some mechanism for obscuring the light from this object on one side, such as an interstellar analog of Saturn's two-toned moon Iapetus, or perhaps dust or outgassing, a change in the object's apparent size could explain the large brightness variations. It's not surprising that this thing is tumbling, but seeing an object so fully stretched, like a rock that's been worn for a very long period in a river or ocean, makes this object all the more remarkable. The second strange characteristic appeared as we followed Oumuamua's route out of the solar system. We thought, maybe naively, that it would follow a hyperbolic orbit, as if the only force acting on it was gravity. What we discovered, however, was that a regular, fully hyperbolic orbit did not suit what we saw. It felt as if there was an extra acceleration. While no concrete evidence has been found to support this claim, the unique characteristics of Oumuamua continue to fuel intriguing theories and imaginative possibilities. Some propose that Oumuamua's peculiar shape and elongated dimensions indicate a purposefully designed spacecraft. Its unusual trajectory and high speed also hint at a possible propulsion system beyond our current understanding. The object's origin from another star system raises questions about potential advanced civilizations in the universe, prompting speculation that Oumuamua could be a probe sent by an alien civilization to explore and study other star systems. Furthermore, the absence of a coma or tail typically associated with comets adds to the mystery surrounding its composition and origin. Oumuamua's tumbling motion, which suggests a non-natural object, further ignites the imagination, resembling how a spacecraft might behave. Oumuamua travels in a complicated tumbling spin as well, but a functional solar sail would have a far smoother route and evident radiation-driven acceleration, according to Jackson. He indicated that the spinning motion of a broken solar sail will be significantly more heavily impacted by radiation forces than apparent. He also stated that the solar sail would be thinner than the authors of the current research indicate. The sail on Icaros is 7.5 micrometers thick. A spacecraft and sail combination may have a large net mass, but the sail must be extremely light. Their estimate of how far it might travel before disintegrating would also be modified, but, as I have mentioned, I doubt any viable vessel would deploy its sail in interstellar space. As Carl Sagan famously said, "Extraordinary claims require extraordinary evidence," and this paper lacks any evidence, let alone extraordinary evidence. In March, Jackson published a report in the monthly notices of the Royal Astronomical Society proposing that Oumuamua originated from a binary star system or a system with two stars. According to Jackson, the spectral data obtained from Oumuamua resembles that of an asteroid or a comet, rather than a solar sail, which would exhibit distinct differences. The current report suggests that the sail might be covered in interstellar dust, thereby obscuring its true spectral signature. Once a functional spacecraft reaches interstellar space, it is highly likely that its solar sail would be retracted to avoid damage, Jackson added. When you are sufficiently far away from a star, the sail becomes ineffective, and there is no reason to keep it deployed. It would be remarkable if the sail could be deployed again upon approaching the solar system. Even if it were left deployed, dust accumulation would predominantly occur on the leading side, similar to bugs on a car windshield. The investigation into Oumuamua's nature and origin continues to be a subject of debate and speculation within the scientific community. As our understanding of the cosmos expands and technology advances, future missions and observations may shed more light on the mysterious interstellar visitor. Whether Oumuamua will ultimately be identified as an extraordinary artifact of extraterrestrial technology or a natural celestial object, the quest to unravel its enigma serves as a reminder of the ongoing pursuit to understand our place in the universe. Regardless of the final verdict on Oumuamua, the quest for answers persists, driving us closer to unlocking the mysteries of the cosmos and potentially uncovering evidence of life beyond our planet. That's all we have for today. As we venture further into the unknown, we eagerly await the next celestial enigma that will captivate our collective imagination. Thanks for watching and subscribe to get an update on our next video.